Right, so on the agenda today, I will first take you through the problem we are trying to address, and that is classifying trading signals for Bitcoin using deep learning. After that, I'll speak a bit about the role of artificial intelligence in finance and how we can use machine learning and deep learning to build accurate predictive models to help us make better financial decisions. Thereafter, we'll look at a demonstration using MATLAB, where we are going to see how a machine learning workflow is applied when building models to classify trading signals. We'll then talk a bit about machine learning interpretability, where we are trying to understand the decisions that our models are making. After that, we are going to look into some conclusions, and then we will then I will point you to some further resources before we have a Q&A session at the end. Right. Now, before we start, I'll start with a disclaimer that, I am not an investor nor a financial advisor. I am not advocating any trading strategy or methodology. This is purely for educational purposes and to demonstrate how easy it is to use MATLAB to test these kind of models and backtest them on your data sets. Okay, now the challenge for today is that I'll pretend to be an investor, and I'm posing the question, can we use some information in the past to predict whether Bitcoin will buy or sell? For example, we'll try and predict 60-minute returns for Bitcoin using some deep learning techniques. We're going to use historical intraday data. So we'll take some recent returns and some technical indicators, and we're going to create a model that will predict those returns as well as classify buy and sell signals. We are going to create a long short-term memory network, or LSTM, which is a type of recurrent network that is designed to work with sequential data such as text, signal, or time series data, where information from earlier in the sequence may be important. Finally, we will look at backtesting the model over a suitable period of time to see how well it performs. Now, before we tackle our problem, I'd like to briefly talk about the role of artificial intelligence in finance. Artificial intelligence, or AI, is used in the financial service industry to automate, enhance, and optimize processes. It helps financial institutions and businesses to quickly build accurate predictive models that enhance decision-making. Traditionally, we would have to develop code and the logic behind a solution to a particular problem. But with AI, all we need is data, which we feed to a model, and the model does the work for us in understanding the complex relationships in the data. These predictive models can be applied around issues like fraudulent credit card transactions, digital wealth management, algorithmic trading, lending, and more. AI in finance includes machine learning and deep learning, which are some of the tools we use to build these powerful predictive models. And we have natural language processing and sentiment analysis, which are used to analyze the news and monitor social media to build sentiment measures of the financial market, which can be used when making trading decisions. And then we have graph algorithms to make visual representations of the data and other techniques which can all be applied using MATLAB. So it's quite interesting what we can do with AI today. So we are going to look at a typical machine learning workflow where the first thing we do is we access our data and import it into MATLAB. We start by importing the data into any platform, in fact, but MATLAB allows us to import from multiple sources such as text files, spreadsheets, data feeds, websites, and so on and so forth. We will then pre-process the data. That is the step where we want to prepare our data in a way that will make sense to the model. In this step, we can clean the data by removing outliers, missing values, and any other data that does not convey useful information. And then we do feature engineering, which is where we determine useful features in the data that will be used to train a model. In this case, the advantage of using deep learning is that it simultaneously performs feature extraction and predictions within a neural network architecture. And this eliminates the need to perform manual feature extractions prior to developing a predictive model. During training, the model learns patterns in the data to determine how to get to a buy or a sell signal. We can then code the model, or we can use a cool MATLAB tool called apps, which allows you to interactively build your model, and we'll see how to use that in MATLAB. Once the model is built, you can export it as a MATLAB variable or a function. Now, once the model is trained, we can validate it. And then this is where we tune the model by changing hyperparameters to try and improve the accuracy. We can use a trial and error approach to determine optimal hyperparameters. However, you will see in MATLAB that you can also automatically tune these parameters to get optimal settings. If all goes well, then we'll backtest the model on unseen data to see how well it performs. Okay, so this is just a diagram that shows how the workflow works. So we are importing the data, pre-processing the data, where we are removing outliers. And then we do feature engineering, where we extract features from the data. In our case, when we use deep learning, feature extraction becomes automatic. And then we train our model, either by coding the model or by using apps to interactively develop the model. Then we tune the model to try and improve accuracy. And then once we are happy with the model and have tested it, we can then deploy our model. Now, let us shift our focus back to the challenge for today. I'll demonstrate to you how we can use AI tools such as deep learning to classify trading signals. So let's jump into our tool of choice, which is MATLAB, to see how this is done. Right, welcome to MATLAB. For those who are familiar with MATLAB, this is the typical MATLAB view that you are used to, where we have the current folder that shows you the folders that you currently have access to. And then we have the command window where you can type quick MATLAB commands to test out your code. And then on the right, we have the workspace where all the variables that you have will be stored. And then here we have our script. So in our case, we'll be working with a live script. And the advantage of a live script is that once you open it, it allows for you to type your code and your comments in a document type of format, which then allows you to be able to read your code as if you are reading a document. And then once you have ran your code, you can be able to get your outputs printed in the same format, in the same document. and then you can then go as far as exporting that code into a PDF or a Word for anyone else that would want to read the document or the code that you've gone through. So we are going to use deep learning, specifically an LSTM model to classify trading signals for Bitcoin. So as seen in the workflow, we will start by loading the data into MATLAB. So to load the data into MATLAB, we use a function called load, and then we have the data stored in a file btcdata.mat. So just load, and then you can run this section. So there are a couple of ways you can run the section, and I think that's the cool thing about MATLAB is it allows you to run your code per section if you want, or you can run the whole script at the same time. So to run a particular section, you just need to click on the section, and then you can see there's a blue highlight on your left, which you can double click, and then it runs that section for you. Or you can click on the section, and then you come up here and click on the button Run Section, and then it will also run that section for you. And then once you go to the blue bar there and you double click it, it takes you back to the MATLAB visualization. And then we can see that on our workspace, there is a variable called data BTC, which is the data that we have just loaded. So we can open that variable and see what it contains. And we see that it contains timestamps, open, high, low, and close prices, as well as the volume for Bitcoin. So we'll keep that variable and use it later. Right. So the next step is to pre-process our data. And how we do it is we want to transform the table that we have just loaded into a timetable. And the reason we are doing that is because we are working with timestamped data or a time series data. So by converting a table to a timetable, it makes it easier for us to manipulate that data. So we'll come to this section, and then you can either double click on this blue bar here to run the section. And then once you've run the section, we can see that a variable data BTC appears. And if you see the variable type, it's a timetable type now. It's changed from table to a timetable. And you can also open that variable, and you will see that it is a timetable with the timestamps, the open, high, low, and close of Bitcoin, as well as the volume. Right. So now that we've transformed our table to a timetable, the next step is to prepare our technical indicators. And the technical indicators that we are using are the relative strength index, the Bollinger Bands, MACD, the Williams percentage R, the momentum, the highs and lows. Yeah, there's plenty of other indicators you can use. In fact, if you go to the MATLAB documentation, and I'll just click on this link here. Just one moment. And then I'll just try and drag this across. You can see that the finance toolbox in MATLAB provides multiple functions of the technical indicators that we can use. So you can pick any of the indicators that you find useful for your analysis. However, for now, we are going to be focusing on these ones that I've just displayed. Another cool thing you can do is you can, in the process of pre-processing your data, you can also do some visualizations just to see how your data looks like. So for example, we've opened the timetable. You can go up to the bar here and click on that bar to highlight the dates. And then you can press Control, hold Control, and then click on the open to also highlight open. And then you can go to the tab plots, and then you can just select a plot. And then that should display, okay, I'll have to drag this across. So that displays to you what the open prices are for the given time that you've selected. So you kind of have a view of what your data looks like. So you can do this for open price, for highs and lows and close. So let's try, say, plot the highs. So you can click on your time stamp and then hold Control, click high, and then go to plot and then press plot. And then what you should get is a plot of all your highs. So by looking at this, you have an idea of what your the data you're working with looks like. Right. So we have imported our data. We have pre-processed our data, prepared our technical indicators, and then we move on to set some dates. So the reason we're setting some dates is we want to select the dates for our training data and also for our backtesting data, because once we finish with training this model, we'll then backtest it on some data as well to see how well it performs. So we'll run this section to create some dates, and then we'll do some normalization on the data. And we kind of normalization that we do is because we are trying to predict 60-minute returns. So we use a daily normalization where the normalization window is 24. So we divide by 24 hours. So we're going to run that section as well. Okay, so it is giving us an error. It's a function variable x that is unrecognized. Okay, so we'd have to just try and scroll up and see where we have defined the variable x. Okay, so let me just try to debug, and I'll do that by putting a breakpoint there and then running the code to see what happens. Okay, so it got to that breakpoint. And then if we try to step once, okay, so the reason for that error was because there's a section that I skipped. So by rerunning your code from scratch and then putting a breakpoint there, you're allowing for all the sections that you've skipped prior to run until the point where you have a breakpoint. So then that variable which was missing is then accounted for. So I'll remove that breakpoint. And then, so we have now normalized our data, and then we're going to move to a point where we want to partition our data into 3 sets, where we have the trading data, the validation data, and the testing data. So our model depends on training data because this is the data that it's going to use to try and find patterns and understand the relationships within the data. So this is the section where we do that partitioning. We can then run that section. Once we've run that section, it then creates partitions of our data. And then we also build our response variable. So a response variable is basically the output that we are trying to predict. So we'll give our model the data, and then we expect it to give us an output of whether we are buying or we are selling Bitcoin. So here is where we create those response variables, which are longs and shorts, or buys and sells for if we use other terms. Okay, now that we have pre-processed our data and we have created our response variables, we now look at building our model. So the model that we are going to build is an Lstm network, which, as explained before, it works best on time series data. So all we do is just create a fully connected layer. So what a fully connected layer is, basically what our output will be. So our output will either be a buy or a sell. So our end fully connected is basically telling us how many outputs are we expecting, which is just 2 outputs. And then we create the features that we are going to be using for the network. And then we just build our layers manually like that. So the sequential input layer is the input layer where we'll be putting in our input data. And then we have the LSTM layer, which is now the layer that will be working towards finding the relationships within the data. And then at the end, it should give us a classification layer, which is now giving us the outputs of whether we are buying or selling. So that's one way of building a network. Another way is you can use an interactive way, which is you go up to apps, and then you come and click on the arrow down here, and then you look for machine learning and deep learning, and then you look for deep network designer. Okay, so the cool thing about using apps is that it allows for us to be able to build these networks even if we don't really know how to code. If you know the structure of the network that you're trying to build, you can just use an app, and then you can add into your app the blocks that you are trying to define, and then you can be able to export that app into a code that will be automatically generated for you. So I'll just drag these across as well, so you can see what it looks like. So in your app, you want to then go to new, and then new. And then here, this is where you can select the blocks that you are trying to utilize in order to build your network. So you can just basically drag and drop all the blocks that you're trying to use. And then when clicking on a block, you can then redefine the parameters of that block. So with an STM network, we would want to have an STM layer, and then we can define our parameters for the STM layer. We would want to have also an input layer. We would want to have an output layer. So all these blocks, you can then drag them across, and then you can easily connect them one to another to show the order in which these blocks are connected. And then once you are happy with your network, you can then come and click on export, and then it allows you to generate the code that builds this network. So you don't have to type the code from scratch, but you can generate that code and then use it for whenever you want to call this model. So yeah, I'll just close this and continue. So in our case, we just defined our model like that. And then we have a function called analyze network, which when you run it, go back to live script. When you run this section, it will then show you if your network is okay. So let me just drag this across. And we can see that it shows you how your network is built. in terms of what your input is, your model, and your layers. And it's a network with 6 layers. And it also shows that it's all connected without any errors or warnings. So you can just use this function to test if your network is connected properly. So the next step is to set some training options. And the training options here are basically the methods that we use to try and improve the accuracy on our data, on our model as we are training. So we have, for example, solver names here, such as the stochastic gradient descent or the root mean square propagation or the adaptive moment estimation. So these are the types of methods that we use to minimize the error that we are getting when we are looking at what our model predicts versus what the actual result is. So in this case, we will try options such as the Adam solver name, and we'll try an initial learn rate of 0.001, and then we'll try a mini batch size of 64 and a max epochs of 40. So what a learning rate is, essentially, it's basically the rate at which your network learns. Yeah, it's basically the rate at which your network learns, and it comes from your error, which is the root mean square error that you get when you are comparing your predicted values to your actual values. So that function gives you it's a parabolic shape, which when you take the derivative of that parabola to get the gradient, that gives you the rate at which that network learns. So that's the initial learning rate. And then the batch size is basically taking your data set and splitting it into small batches. And the reason we are doing that is so that so generally these networks, they need a lot of data to train. So if we are to calculate the loss of, or if we are to calculate the running loss of our function, it will be very expensive if we do it on each and every single data point or each and every single data point. So what we're trying to do is combining all these data points into small batches, and then we consider one batch at a time. So if we look at our data set, which is Bitcoin prices, we'll then take the whole data set and then split it into 64 batches. And then an epoch or max epochs is basically the number of times that our training goes through all the batches. So it's basically an iteration. For epoch to be 1, it means that our model needs to go through the first 64 mini batches. And then for epoch to be 2, it means that our model needs to go through an iteration of 64 batch sizes again. So those are just the training options that we are going to be selecting. And then let's run that section. And then once we have done that, we are going to the point where we want to train our model. So the cool thing about MATLAB is when we train our models, there will be okay, so that gives us an error. Okay, so let us try and debug this error. We'll just put a breakpoint there and then try and run our code from scratch. And then we'll see. Okay. Network analyzer. All right. So yeah, so this is the pop-up that comes out when you are training your model. So it shows you what your model is doing as it is training. And then you can also see the results on the side. We are looking at 40 epochs. So it's currently at epoch 5. So it has gone through 5 iterations of all those mini batches. And then, yeah, as soon as the model is done, you will then be able to get the accuracy of your model as well as a loss function, which you can then try to improve on, depending on whether you are happy or not with your results. So it takes a bit of time to train because we are working with large data sets. So I think for demonstration purposes, I tried to make the training as short as possible. So we can just give it a few more seconds to finish, and then we can look at trying to analyze the results. Okay, so yeah, in the meantime, while it is training, I'll just remove that breakpoint. So it means that we have sorted out that error which was appearing. So you then, after training your model, you then save the model in a variable. So we used a net Lstm classification. And then that means now that whenever we want to use this model, we can always call this variable that we have saved the model into. Okay, so yeah, the next step now is to test our model. So in order for us to test our model, okay, there you are. So these are now the results of training. We've given our model some training data. We've let it train itself and find patterns within that data. And we can see that our model is just fluctuating between 40 and 60% in terms of accuracy. So it means that every value that it predicts is about 40, 50, 60% accurate. Okay, so let's look further to explain what this means. And we'll do that by testing our model on a testing data set. And how we do that is we load the model, which we have saved, and then we use a function called classify, and then we give it the network that we've just trained, and we give it a testing data set. So remember when we were partitioning our data up there, we wanted to partition our data such that we have a portion for training and a portion for testing. So when we test our model, we test it with a portion that it has not seen before, but it should be able to use what it has learned from the training data to try and predict what the output of this testing data will be. So the testing data is also Bitcoin data with the date, the highs, lows, and open and close and the volume. And then from that data, we should be predicting whether we are buying or selling Bitcoin. So let's run this section. All right. So once we run this section, okay, in fact, let me just try and do this. I'll put a breakpoint there because what I'm trying to do is not display these plots yet. Okay. Okay, so I'm going to run that section and okay. So let me just drag this across. And then, so here we have ran our model on testing data, and then we want to see how well it predicted our outputs, which is the longs and the shorts. And this is now a confusion matrix. And how you read a confusion matrix is you can see that on the y-axis, it's got the true class, which means that these are the true sells and true buy signals. So this is when the market went long and when the market went short. And then on your x-axis, we have our predictions. So we have our predicted longs and our predicted shorts. So if we look at the first block here, we can see that our model correctly predicted 161 longs, but then it misclassified 165 longs as shorts. And then similarly, if you look at this block, we can see that our model correctly classified 206 cells, and it misclassified 170 cells as longs. So if we look at the block on the right, it shows us that in terms of longs, our model was 48.6% accurate, and our misclassification was 51.4. And then in terms of shorts, we have a 55.5% accuracy, and then we have a 44.5 misclassification. So not a very good model, but then there are a couple of ways that we can improve on this model. One of them being that we can go back to the training options that we defined here, because these now determine how our model is going to learn. So we can manually tune these parameters to find the best combination, and that is often a very tedious workout. But another way to do that is we can create a function, and that function is basically an experiment. So we want to run an experiment that will automatically tune our parameters and find the best combination that will give us the best results. So if we go to apps, and then we go to the down arrow, and then we look for experiment manager. So in the experiment manager, we can start a new project, built-in training, and then just save that. And then here, we now want to go back to our current folder, where we want to use that function that we've just created to then experiment on it so that we can try and find the best parameters for our model. So if we go back to, okay, I'll just find. Okay, so this is the function Bitcoin experiment. We'll just want to copy that function, and we copy it to the experiment that we're trying to run it in. So we'll delete that, and then so this is the function that we're trying to experiment. So in this function, it contains the hyperparameters that we are trying to play with in order to find the best combination. So the next step is we'll come to here where we'll type the function that we are trying to experiment on, and this is Bitcoin experiment. And then this is where we add the hyperparameters that we want to tune. So the first one will be the solver name. And then here we just want to tell the model which solver name to use as it is trying to find the best combination of these hyperparameters. So we can try the Adam solver. And we can try the stochastic gradient descent. And because these are strings, you must make sure that you put them in double quotations. And then you can also try the third solver name, which is the root mean square propagation. So that will be the root mean square. And then that's the first hyperparameter. And then we can add the second hyperparameter, which is the initial learning rate. Initial learn rate. So the initial learn rate, we want it to start with 0.1, and then 0.01, and then 0.001. So what this does is, as it is trying to find the best combination of these hyperparameters, it will go through all of them at the same time and then give you a result of which of the combinations will optimize your training. The third hyperparameter is the mini batch size. And with the mini batch size, we can just maybe do two, say 10 and 20, for example. And then the last one is the max epochs, which can be, we can say 10 and 20 as well. All right, and then, so these are all your hyperparameters. And as you are experimenting, you want to try different combinations of these hyperparameters and then see which ones will optimize your training. So you just come here and click run. And then after clicking run, you basically just wait, and then it's going to try out all these combinations. You can see here it's trying the Adam solver name. It's trying the initial rate of 0.1 with a mini batch size of 10 and an epoch of 10. It's going to run that, and then it's going to try the second one with stochastic gradient descent with an initial learn rate of 0.1, a mini batch size of 10, as well as max epochs of 10. And then it will do all these iterations. and then it will then give you which one of these is the best combination that will optimize your training and improve your accuracy. So yeah, we are not going to go through this because it's going to take us the whole day, but it was just to demonstrate to you that it is possible to automate this process. You don't have to do it manually where you have to go and change one parameter at a time and run your model. This is a way you can do it automatically by going to apps. Okay, I'll close this. Okay, stop the trading. Okay. So we do this automatically by going to apps, and then you come and look for an experiment manager, and then you just give it all the hyperparameters that you're trying to experiment with, and then it should then be able to run that process for you and give you an output that tells you which of the hyperparameters will optimize your training. Okay, so that will then help to improve your accuracy as well as your loss function. And then now the next step will be to then try and backtest our model. So we've built this model and we have trained it, we have validated it. So now we want to backtest it and see what results it will produce. So we first create the model and then give it some returns. And then we want to then plot this model against the true Bitcoin models or the true Bitcoin values and see what the output will be. So I'll first comment out Bitcoin. And then I'm going to run this section. So this now shows us what our model is predicting. And then if we then compare that with Bitcoin and run this section again, we can see that Bitcoin is in orange there, and our model sort of tries to trace Bitcoin. The shape looks almost the same, but then there are some points where Bitcoin is selling a little bit earlier than us. And then also Bitcoin buys a little bit lower than we are buying. But like I said, if we go back to tuning our hyperparameters, it will help to improve this output. So yeah, we have come to the end of our experiment where we were trying to build this signal generator, I would say. Okay, so the next point I want to touch on is on interpretability. So let me just go back to the slides and discuss a little bit about what interpretability is. So we have built these models and they are fantastic. They produce amazing results. But here now we are trying to understand the mechanism behind these model predictions. AI models are often referred to as black box because the representation of knowledge is often very difficult to understand. Thus, we use interpretability techniques such as the decision trees, individual conditional expectation plots, partial dependency plots, and others to help us understand why a model makes the prediction that it does. And this is important for the following reasons. Number one, when we are debugging, which means that we're trying to understand where and why the prediction goes wrong. And then secondly, it's for guidelines, and this is in order to not violate corporate technology and best practices. And then thirdly, it will be for regulation purposes, because some government regulations require interpretability for sensitive applications, such as in finance and public health and transportation. So you don't want to bring models that cannot be interpreted or explained or understood, because when they break, it will be difficult to justify where and why they broke. So by being able to interpret a model, we increase the trust in the model in situations where explanations for predictions are important or are required by regulation. So before we conclude, we can just go back again to MATLAB to just demonstrate one technique that we use to try and interpret our models. So in this technique, we are going back to the Lstm network to then see how the predictions are done within the model. And so we will be looking at a heat map, which will show us what features dominate in the model trying to predict our outputs. So if we go back to our live editor, and then we'll just run this section to do some initializations. And then let's run this second section. And so here, try and expand that, drag it across. Okay, so here we have a heat map, and what it shows us is all the hidden states of our network, which are basically the features of that we are training our model with. And then here we're looking at time steps. So what this does is it looks at each and every feature that is in the model, and then it shows us where exactly in time do these features become important as our model is training, right? And I think this is a very not easy to understand representation, but if we go further down to run this section, then it becomes easier to explain that here we are now ranking these 13 features that we have by order of importance. So the 13 features that we have, I'll just drag these across so that we can all see them. Okay, let's remove that and continue. Okay, so this now shows us what our network sees as important when it is training. So we can see that the highest is the lowest lows. So it uses the lowest lows to predict, I would say, a buy signal, and then it uses the highest highs as the second most important, and I would say to predict your sell signals, because you want to buy low and sell high. And then you start to have your indicators by order of importance. So we can see that the momentum indicator was more important. And then you have your oscillators, your Williams percentage R, MACDs, and your Bollinger Bands and your relative strength index. So it just shows you now what your network sees as it is trying to train itself with all these features that you've given it, and to a point where if you have some features that you feel are not as important, you can then remove them to help improve your model in terms of training time and maybe accuracy. It's something that, you know, you might have to check once you're training your models. But with this, then you tend to understand that the lowest lows and the highest highs become very crucial as your model trains. So you want to focus on that a lot more, so that if your model breaks, then you know how to explain that situation. Okay, so yeah, that is one way we sort of try to interpret what our models are doing. And then there are multiple other ways that we can try. But for the sake of time, I think I've just highlighted them in the presentation. So yeah, in conclusion, we have looked at our problem, which was to classify trading signals for Bitcoin using deep learning. And then I went in a bit to speak about the applications of artificial intelligence in finance. And then we looked at a demonstration where I was showing how we can classify buy and sell signals in MATLAB. And then we looked at how we interpret the outputs that we get from the models that we build. So with that, are there any questions so far?
Yeah, I don't know if I can just chip in.
Okay, yeah.
Right, sure. Like I have a couple of questions. You were I can't remember with your solvers. I can't remember the actual names, but you seem to have sort of we didn't outline what's the merit of using one over the other, so which is a little bit confusing to me. So if you could probably just give us a brief, and as far as which solver it works where and why does it work in that particular instance, and if it does, and if there's one that doesn't work as well, why doesn't it work? Because I feel like that will add value to your presentation, and as far as us understanding why are there different solvers to begin with. And my second question would be on your very last slide when you show the effectiveness of those, should I call them vectors? The first three, as I wrote on the chats, they're pretty much momentum based or momentum related. So when you talk about the highest highs or the lowest lows, the momentum itself, that everything is related to momentum. The only thing that is in question maybe is it the term, or should I say the term of that momentum? Is it a 1 week momentum? Is it a 3 week momentum? Is it a 12-month momentum or something like that? So why do you treat them as different? Because I feel like that can lead to sort of like wrong interpretation of the results. Oh, thank you. Those are my questions.
Okay, thank you for that question. Those are very interesting questions. Okay, so let's start with the solvers, okay? So the reason we use the solvers is basically to minimize the loss or the error that we get when we compare the predictions to the actual results. So the error is calculated using so you get a mean square error, okay? So with that mean square error, if you use the stochastic gradient descent, what stochastic gradient descent does is it minimizes the loss function by taking small steps in the direction of the negative gradient of the loss using momentum to reduce oscillation. So and then you have the root mean square propagation, which uses the learning rate that are different for different parameters. So as you switch parameters, it changes the the learning rate as well. And then you have the ADAM, or the adaptive moment estimation, which is similar to the root mean square propagation as well. So you are basically trying to reduce error. And when you do that, you are basically, I would say, trying out these solver names to see which one best fits your particular application. Initially, we were using the Adam solver, and we saw the results that it gave us. So we just wanted to try out other different solver names to see if they will improve our error. So the idea is that it's a trial and error thing. If you're not happy with the kind of output that you get, you can quickly try another solver to see if it will improve or make your results even worse. So there is no, I would say, particular application. Some of these solvers work better in different other applications. Like if you are doing image processing, maybe the Adam solver could work better, but it will be worse when you're trying to do time series. It's all about trying out the different solvers and seeing which one best fits your model. Now, secondly, the question you were raising about the indicators being related to momentum. I think that's because of the types of indicators we chose for this particular demonstration. You can really choose any indicator that you want to work on, and that will be a feature of your model. So in our case, we chose the momentum, stochastic, we chose the momentum, we chose the RSI, we chose the Bollinger Bands, and you can really choose any of the indicators that you want for the results that you're looking for. So I'm not sure if I'm answering your questions to satisfaction.
Yeah, I'm good. Thanks.
Okay. All right. So yeah, this is where you can reach me. This is my email. And then for support, you can reach us here at support@optinum.co.za. And then, yeah, there are multiple resources we can find when you visit the MathWorks website with some videos and examples. And then there are also some training courses there.
Yeah. Thanks, Simbilani. Thanks a lot, and thanks guys for joining. I joined late. My name is Siche, and I'm actually the account manager in the financial services industry. So I'd just like to ask if you'd be open to getting maybe like an email. I'll be sending emails to you guys, maybe to set up like some time, maybe 30 minutes meetings to just try and understand your business and what you do better, and where we can add value maybe as Optimum Solutions, because we do work a lot with a lot of companies in the financial industry. So maybe if I can set up like maybe some 30-minute meetings with each and every one of you, yeah, just do a discovery, find out what you're currently doing, what your plans are, and what you're using MATLAB for, if you are using MATLAB, and where we can help. Yeah, and do that. Is it something that you'd be open to? I guess I'm asking Samuel, Sneklasha, and Pavalo. See a thumbs up there from Samuel. Okay, perfect. Yeah, I think you can proceed to Milani.
Okay, all right. Okay, so just wrapping up, we have some FAQs. Otherwise, if you've got any specific questions, I think the floor is open for addressing them. All right. Yeah, I really can't see if there are any questions. Maybe a few thumbs up if you are good. Otherwise, just throw questions. We'll try and go through them.
Yeah, Tsimbilani, I also don't see any questions coming through in the chat.
All right. All right.
Yeah,
Cool.
but I saw a thumbs up.
Okay. All right, cool. Thank you. Thank you everyone for attending. I hope that this was valuable information to you and information that you might want to use in order to, I guess, improve your trading strategies going forward. Thank you very much.
Thanks, Timbalani.
Thanks everyone. Thanks, Tsimbilani.